Hey everyone, so I was thinking since interview season's coming up and I personally need to prepare for interviews, that'd be a good idea to start making these mock interview videos again. Yeah, so hopefully this question's not too bad. Okay, so it's called triangle. Given a triangle, find the minimum path sum from top to bottom. Each step, you may move to an adjacent number on the row below. So basically, you can go from top to bottom, and you can only go left or right. Okay, so this seems like kind of dynamic, kind of a dynamic programming question where at each step I want to save the smallest sum that it takes to get there. So let's say this is 2, right? So add 2 to 3, so 5, and add 2 to 4, so that's 6. And then when I get down here, I add 5. I think it's better if I write this out. Okay, so it's like 2, 3, 4, 6, 5, 7, whatever, right? So at the top it's still 2. And then I add 2 to 3, so it becomes 5 and 6. Then over here, I add 5 to 6, so it becomes 11. And then on the right side, on the very right side, it's 7 plus 6, so this becomes 13. And then what's in the middle? It's 5 plus the minimum of the top 2. So that would be 10, because 5 is the smallest out of these two. And then I think I do the same here. So on the very edge, there's only one path to get there. So yeah, so it's 4 plus 11, so that's 15. Then over here it's 1 plus the minimum of the top 2, so it's 10, so it's 11. 8 plus the minimum of the top 2, so that's 8 plus 10, so it's 18. And then 3 plus 13, which is 16. So then the shortest path is, then you just get the minimum of the bottom row, which which is 11. So basically what I'm doing is I'm not trying every path. I'm just I'm saving an array of numbers of the previous level, because I don't need to know all the paths. At the very bottom level, I don't need to know all the sums of the levels above. I just need to know the smallest sum it can take to get to each of the numbers above me. If that still doesn't make sense, leave a comment, and I respond pretty quickly. So yeah, because I know I'm much better explaining. I won't have time to think about it. But yeah, so that's pretty much the algorithm. What I usually if you watch my previous videos, what I just say is when I have an idea of the algorithm, I just start coding, and then I figure the rest as I go. So yeah, let's get started. So I have a vector of vectors. So I will have to loop so I'll have to loop through the triangle, like loop through the outside vector. At this point, I'll ask if I can modify the triangle, because I don't really need to know about the original triangle. I can just, if I could, I would just modify it, so I don't have to allocate another triangle. But if they're like, no, you have to make a new triangle, then yeah, then I'll just make every level as I go. So one thing I'm thinking about is if I should do this iteratively, or if I should sort of do this recursively, or if I should do this all in one loop, or if I should make a helper function. I think I'll try to do this iteratively first, and then if I can see some way to optimize later, then I'll do that. So int sum equal to 0, and then return sum. Okay, and then for int equal to 0 while I is less than triangle dot size I plus plus plus. Alright, so this is where I am looping through outer triangle. Then for every one of those levels, let me think about this for a bit. Looping through outer triangle. So then if I'm at 2, okay, I need to have a vector prev level, so that, yeah, so if I have a previous level, then I can sort of update my current level. So vector current level. I might have to have this on the outside too. No. Then I'll have another. So then I'll have another for loop. So for j equal to 0, while j is. So right now I'm filling out current level. While j is, so then first, okay, at this time I'm gonna ask, can I have like 2 minutes to think about this? And they'll be like, sure. So I'm gonna ask for 2 minutes. Okay, so for my current level, look at the previous level. So how many elements are there for me at this level? It is So then that's how many times it's run, and then for every one of those times it looks up at the previous level. Okay, and then okay, and then so prev level, should I start at 1? Okay, so I guess this is my current algorithm. So I'm looking, I have a previous level, and then I'm looking through the outer layer of the triangle, and I'm filling out a current level vector. So I handle the leftmost case, which is just the min sum of index 0 of previous level. So prev level 0. And then for the rightmost case, I push back prev level at I. Yeah, at I. Then for the centers, I push back the minimum of, so then the minimum would be prev level at, so okay, for 10, this is index 1, and I want 1 and 0. So it would be at j and prev level j minus 1. But the thing is, I have to add that number to whatever, right? So, what I mean by that is like add the current number to the previous sum. So plus triangle, so plus current num. And then current num will be, wait, so messy. Triangle at I 0. Okay, and then we have to first set prev level 2. So prev level will now become current level. And well, actually that's like most of the algorithm. I just have to now account for the edge cases. So so first two edge cases I came up with was empty tree and handling first level. So if the thing is, if it's the first level, the leftmost will also be the rightmost, which means I'll be pushing the same thing on twice. So what I could do is just do this, and then this is kind of messy, but if triangle dot size equal to 0, then we just return 0. So after that, then we know there's at least one level. So the first level, we just do sum equals the triangle at 0 at 0, and then prev level dot push back sum. Okay, and then basically at the very end we just want to loop through prev level and choose the smallest one. So actually we don't even need sum. Okay, so if it's an empty tree, we just return 0. Otherwise, we fill prev level. Then we loop through each level, and we fill out the current level. So we first fill out the leftmost ones, then we fill out the center ones, then we fill out the rightmost one, then we set the previous level to the current level, so the next level can use the current level. At the very end, we just loop through while I is less than prev level dot size I plus plus, and then int min sum equal to 0, and then min sum equal to min of min sum and prev level at I. And then at the end we just return min sum. Okay, so that was like a very roundabout way of getting to the solution. So I'm gonna walk through. This is, I always say this. So this is the rough draft of my algorithm. Now I'll just talk you through. I'll talk through my algorithm again. So first of all, I initialize a previous level vector so that I can use the previous level's min sums in order to figure out my level's min sums. Then I first account for the empty tree. If it's an empty tree, I just return 0. Otherwise, I know that there's at least one level, so I push the top level's single number into prev level. Then I'm ready to go through the rest of the levels. So I loop through all the levels using triangle.size, and then I initialize a current level vector to keep track of the min sums of my current level. I handle the leftmost because in the leftmost case, I can only take the leftmost number on the previous level. So I do that and I add it to my own leftmost of the current level. So add that to the level, then it handles the centers by going from the second element, and I loop through all the way up and just before the last element. And so this might be an off by 1 error, but let me just make sure. So let's say on the first level, I will be equal to 1, and 1 plus 1 equals to 2, so j will only go up to 1, but I want it to go up to 0 because the last index is I, so I want to go before I, and then I increment j. So then at each of those I want to look up, and I want to take the one top left and the one that's top right. So how I do that is using previous level. The top left would be the number at j minus 1, and top right would be the number at j. And then after that I just add that to my current number. And then same thing over here, I just add the last number to my last number. And then at the end of this, I set prev level. Okay, so after all of that is done, I processed every level, and even though I only care about the last level, so yeah, then I just want to take the minimum of my current level, or the last level, which is now prev level, previous level. So I just loop through previous level, and I just keep taking the minimum. I keep comparing and saving the minimum value, and then at the end I return that. Hopefully this just accepts. Oh man, missing template arguments for prev line 15. Oh shoot. Vector. So basically what's happening is I didn't define what the vector contained. Please, 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 please. Oh, what? What? Ah, man. Okay, well, the shortest path is 3, but I'm returning 0. Why is that? Okay, well, there's 1 and then 2, 3. So triangle.size is equal to 0, return 0. But the triangle's size isn't that. Afterwards I push back 1. That was so weird. Alright, let's try this. So 1 to 46 and 1 to high. But then what about this? Forty-six highs. Okay, so it knows at previous level. Oh, okay. So the thing is, that was a pretty big mistake. Can you figure out why? So, yeah, so given this test case, this runs twice, so meaning that it does know that previous level has 2 numbers, but why is it returning 0? Alright, so I'll just count to 5. 1, 2, 3, 4, 5. Okay, so the reason is because I set minimum sum equal to 0, so that when I compare this to all the previous levels or whatever, it just kept keeping 0. So what I should have done is instead just set it to prev level at 0, so that I'm not throwing like 0 into the equation. Submit solution. What? What? Why is it? Why? Fuck. Okay. Okay, so let's see what happened now. So, I think it's easier if I just print out everything on the bottom level. Oops. Alright, so it's -3 both times when it's supposed to be -3 and -4. So then when I'm doing this, previous level plus triangle at II, triangle at II should be -3 in that case, and then previous level at I should be equal to -1. So this is what I say you shouldn't do when you're preparing for interviews, which is like compiling, running a test case, getting it wrong, and then going back to your code, fixing it, and then compiling it, and oh shoot, like something else is wrong. Yeah. Because you don't really have this luxury in the actual interview. So why am I doing it then? Good question. the heck? Okay, so for some reason, previous level is equal to 0 at I. Oh, wait. So what is the last element of the previous level? So let's say we're on level 4, but which is actually level 3. So 0, 1, 2, 3. Okay, and then 0, 1, 2, 3. So I'm looking for this element. I is 3 right now. This element is actually number 2, so it should be I minus 1. So I minus 1. But then for this one, so this is the last element of the previous level, so it should be I minus 1. And then this is the last element of the current level, so it's just II. Okay, so I got accepted. It took me 31 minutes. To be honest, that wasn't very good. I feel like during an interview, if I was an interviewer, I might have given me a maybe because I solved it. Yeah. I mean, yeah, that wasn't like a perfect. Maybe that was like an okay. But yeah, so I solved the question. Thanks for watching. I'm thinking about making one of these every day, and hopefully as I make more of them, I'll like get into the flow again. Today I felt like a little bit rusty. It's been a while since I worked on algorithms. Please let me know if there's any problems you want to see, or if you can give me any feedback on this. Do you want me to make explanations? Do you want me to just fumble my way through these questions? It's all up to you, the viewer. Yeah. I also have a Facebook page that people have been reaching out to, so if you want to reach out, just feel free to do so. I'm friendly and I want to help. But yeah, until then, thanks for watching and good luck on those interviews.